Hey guys, welcome back to the channel. In our previous video, we created a simple API which would run and expose an endpoint called /live, and we would use that as a health check endpoint to check if the server is running or not. Now, as you can see, we are passing the address here statically. This is not good. But instead of that, we could pass this from our configuration file. By doing this, we make our application much more configurable and tunable. So I have created a config file over here called config.yaml. It has some values: app and name, bookstore API, server, port, and address. Now, in order to load this configuration into our application, we will need to write some code. Let's create a folder called config and create a config go. So this directory will hold our configuration code to load YAML into our program. So let's declare the package called config. In order to load these value, we would need to create a struct. So let's create a type struct. We can write everything into a single, or we can create multiple struct to hold each of them. I like doing it that way. So let's do create a struct to hold the app related configuration, which is name and string, and the YAML tag for this is name. And we create a server, which is a struct to hold this value, and the port is a string. The YAML tag for this is port in lowercase, and address is a string as well, and YAML for this is address. We have created two struct. Now we need to create a global configuration struct type. So let's create a struct which is a config, and it will hold both of these. So app, which is this one, and server with its YAML tag of server. So basically this config will hold app and server struct, which in itself are struct of different values. So now we have created a type struct. We need to create a function. Every time our function run, it will load our configuration into our app. So let's create a function called new config, and it will return two things. One is the config value once the data is loaded, and error if anything went wrong. So let's create a variable called cfg, and it will hold the config values. For now it is empty, so we will use a package called cleanenv. It is a good package which helps you to load the configuration into your program. So basically copy this and install it. Close this. Okay, the package is installed. Now let's call the function cleanenv dot read config. Config takes two values. One is the path to your config.yaml file. Since our config.yaml file is in the same root directory, we can just pass it here, and it does take the variable. What it does is it loads the value from config.yaml file and puts it into our variable. So read config returns an error. So let's just quickly handle the error as well. If error is not equal to nil, then we will return nil in place of config and an error with it. Could not read config file, just to put more add some context into the error. And if everything went fine, we'll just return the config with nil error. This is the configuration or code to load our YAML file into our Go program. Now we did write the configuration, so let's go to our main program, and here we will call config.newConfig, which will load the value and pass it into our program. So it returns two things. One is config and it returns an error. Let's quickly handle the error. If error is, let's copy this. Let's remove this. If error is equal to nil, then it will say could not create new config. And if everything is fine, just want to comment load configuration. If everything is fine, we'll pass the config into our server. So the reason it is showing error over here is our server run function, it doesn't accept any argument right now. So let's fix that. Config.config. So it takes the config as an argument. Instead of passing it like this here, what we can do is we can do config.address plus concatenate the values config.port. So that's all. Basically we loaded the configuration values, port and address from our YAML file and pass it into our server. Now let's try to run it. Let's go run cmd main api main.go. As you can see, the server is running on port 8080. Now if I change the value to 9090, then the server is running on 9090. So yeah, this makes our application much configurable and tunable. We can add a lot of configuration here to make our application like highly tunable. So before we proceed, I would like to introduce another tool. There is a tool called Air, which helps us do live reloading of our application. So every time we don't have to stop the server and start it again. Let's install it. So let's go to the package. We'll install the binary. Yeah, now in order to initialize, we will do air init. It will create a file called air.yaml, and instead of running our application using go cmd, we will just use air binary. You can see it is showing error saying could not find any file. The reason it is happening is if you go to air.yaml, it is looking into .current directory, where we don't have the entry point. So instead of that, we can just do .api/main.go. Now we have passed the entry point to our application. If we do it again, our server is running. Air has started our HTTP server at port 9090. The reason it makes much easier is if I go and change the value to 8080, this will not reload. But if you make any changes to any Go application, just go into any application or Go file and just save it, hit save, it will reload the configuration. Our server is now listening on 8080. It makes the development work much faster. For now, let's just listen on port 9090. So basically what we did in this video is we created a config.yaml file, loaded that config into a struct, and then we passed in the values from the config to our server running. But you can see over here that our run function is doing a lot of things. Like it is creating a router, it is registering routes, and also it is running the function as well. We can make it much better and maintainable and scalable for future as well. So instead of refactoring at the end, let's just refactor it now so that it will be easier for us to develop our application in future. So let's comment this out. We will take this as our reference, and what we will do is we would create a struct type called server, which will hold our configuration and router as well. Yeah, now let's create a function which will create a new server. and this will return our server type and error if things go wrong. Just fix it. So now what we'll do is, instead of running the server directly, we will create a new server and that server would run our application. So let's copy this in here, created a new router, and what we will do is, this new server, we will pass the config to our new server. Config config. So now let's create the server. It will hold the config which we passed in here, which is config itself. The name is same, and for the router we will just use the router that we just created above. So let's return the server. We'll create a pointer here and just do server. Yeah. Oh, sorry. Return and yep. Okay. So basically we created a new router and created a server, assigned the values and returned the server. This process is known as dependency injection. This way we don't have to pass the config and router every single time to any of the function. We can basically make a pointer receiver and use this from the server. Let's create a function to start the server. It will be a pointer receiver which calls start. Notice we are not passing any config to this function, so we can basically run the function. Let's copy this. It will return an error if something goes wrong, so we just copy this here to fix it. So basically, instead of calling router run, now we will do is we will call it through our new server, which is s.router.run, and same for address and same for both. We separated the function to create new server, start new server. Let's create another function to register the route as well. So do the same, register routes to return an error if something went wrong, and we will just do copy this, and we'll just, and if everything goes right, we will just return nil. Now this, it is not on use, so let's remove this. We don't need it anymore. So what we will do is, when the server is created, we will basically, or we can do it like this. We can pass the register the route. We'll use router chain.engine. We'll do it like this, and we will call it from here. Register route, will pass in the router here. Okay, so basically when the server is created, we create a router, assign the dependencies as well, and register the route, and there is another function which will start the server. We can move this into another file called routes.go. Let's create it and call server package, and we will just copy this in here. Okay, now it is much maintainable. and readable as well. So let's go to our main function, and instead of doing this, we will remove it. We'll first create a new server and pass in the config. So it returns a server and an error. Let's assign the values, and if error is not equals to nil, then we'll do the same thing. Could not create a new server. If everything went fine, then what we will do is we'll call server.start. It returns an error, so we'll do error equal to server.start, and if error is not equals to nil, then we will throw in the same error, could not start the server. So we loaded the configuration, we create a new server instance, and we start the server. Let's go to our route. Register route function registers all the routes associated, all the routes. And let's go to let's add some comments. Server is a instance of server which holds configuration and router. New server creates a new instance of the server and returns. We'll just do returns a new server instance. Just do it like this, yeah. And we'll just do starts the server and start the server. We'll just do it like this, yeah. So basically we refactored our application again. Now what we did is let's write the comments here. Check live checks the server is running or not. Routes is fine. So yeah, so basically we did a lot of things in today's video. So we created a server, use dependency injection to inject config and router dependencies into our server instance, and then we use that server instance to start and run the server. So let's test whether our application is running or not. So basically we will do air cmd main.go. Instead of doing that, let's do it like this. Let's create a makefile and call it and it is run server, and let's run the server is it will run air cmd api / main.go runs server, yeah. Okay, go run, let's just make run server. So yeah, our application is now listening. Now in order to test it out, we can use locally as well, but I would recommend, since we will be building the API and the complexity would go even much further, so I would recommend you to download a tool called Insomnia. It's a really good tool and easier to understand as well. So just go to Insomnia and just download the free version, So once you download and install the application, it will look something like this. Just bring in, let me just, it's loading, taking forever. Yeah, it will look something like this. You wouldn't have anything. So let's create a new request collection. I will create a new project. We'll say collection would be bookstore API, and create it. And we will create a folder called health check. This will hold all the endpoint for our health check. We'll create another folder for CRUD bookstore CRUD, which will hold all the endpoint for create, retrieving, deleting, and updating books. So for now we have only implemented health check. So let's create a new HTTP request. The method would be, let's just make it much bigger. The method will be get, and as we have implemented only get, and HTTP localhost colon 1990, as our server is listening on port 1990, and slash live is the endpoint for checking if the server is live or not. Now you can rename the name of the request as well. I like it to do it. So I'll just copy this, and instead of writing new request, we rename it /live. So just close it, it would automatically be updated. So yeah, we have installed Insomnia and added an endpoint. Let's test if it's working or not. So as you see, the method was successful and we got so Insomnia is pretty useful. It's clean. It doesn't have any complexity like Postman is. I find Postman much clunky. To test most of the thing, it is more than enough. So these are the headers and the timeline. That's all for this video. We learned a lot of things. Let's just recap what we did. We created a config.yaml file, loaded into our application using Go. We refactored our application to be maintainable by implementing dependency injection, and we started the server. I hope you are able to follow along. Please comment below if you have any questions or if things didn't work out for you. That's all for this video. See you in the next one. Bye bye.